So in this example, we'll look at a problem where we're not given the entire derivative of our inside function. So we have the integral of square root of 2x minus 3 dx. We let u equal 2x minus 3. Du is equal to 2 dx. And so we don't have this 2 here. So we need to account for that. I'm going to divide both sides of this equation by 2. And so essentially what I have is 1/2 du is equal to dx. So we'll substitute that into the problem. And so what we have then is the square root of u times 1/2 du. And now that 1/2 is just a constant that's being multiplied by this whole integrand. So I can pull that out front. And so I'll have 1/2 the integral of u to the 1/2 du. And so that will be 1/2 times 2/3 u to the 3/2. And so this will give me 1/3 2x minus 3 to the 3/2 plus c. So you can compare that to the example from above. So let's say, for example, I have the integral of e to the x times e to the x to the negative 3 power dx. So here's my grouping symbol, these parentheses raised to the negative 3. So that's what I'm going to make my u. My u will be equal to e to the x, and my du will be equal to e to the x dx. And so we can see our du here, e to the x dx is equal to du, and so we will replace that in our integrand with just du. And then what we'll be integrating will be u to the negative 3 power. And so that will be u to the negative 3 plus 1 divided by negative 3 plus 1. So that'll be u to the negative 2 divided by negative 2. And so that's going to be 1 over negative 2 u squared. And we can substitute in our e to the x. That will be negative 1 over 2e to the 2x plus c.